Hey there! Well, you know how I like to show you some things that are not strictly just related to Java, and I sort of think that it's important to have an idea of the world, the realm of software engineering and what it includes. Well, there's this thing that most software engineers know something about, and it's called design patterns. Design patterns are kind of like architectural ways of laying out classes. And this is the seminal book on it. This book is pretty old. It's by these four people. They're colloquially referred to as the Gang of Four, so this is known as the Gang of Four book. It's pretty terse. It's a rough read. It's very thick. The pages are really skinny and the letters are tiny. So sometimes it's a little tough to get through that one. There's an alternative called Head First Design Patterns. I would recommend this one if you're going to delve into this stuff a little more. Let's see if you're interested after I make a mess of this whole. Definitely not going to do what she says anymore. But what we're going to be looking at is this, which is my favorite pattern. It's called the strategy pattern. See, look, it's real. There's a Wikipedia article about it. You know how these UML things go. I think I can get a prettier one than this, but you've got your boxes for classes or interfaces, then you have the connections. You should know that from last course, from Java 1. I'm looking for a prettier one. Okay, that looks better. This looks better. There's a pattern here. It's always got this sort of shape. So you've got an interface, that's the strategy, and then you have implementations of the strategy that can be switched out at runtime, and they're used as part of the context. Okay, this is the Head First. Yeah, see, there's even a cute chick on there. It's a lot more accessible. So that's where you should go if you want to learn more about design patterns. Anyway, strategy pattern. I'm going to try and make one. Okay, so you probably have gathered at this point that I'm Irish and we eat a lot of potatoes. So that's going to be the example I'm going to use here. We're going to have two Irish people. I'm actually just going to use me and my brother for this. So I'm going to have two people. And my brother, his name is Ian. We like to eat a lot of potatoes. Me and Ian, we have competitions to see who can eat the most, especially when it's mashed potatoes. Anyway, every Irish person has their own favorite way of eating potatoes. For me, it's always, but especially I like roast potatoes. My brother likes croquettes. They're like a little deep fried thing. Anyway, but we're both super into mashed potatoes. I don't know if that's going to be useful in your career as a software engineer, but who knows. Okay, so I'm going to make my strategy. You know we've got these people. I'm going to use a UML thingamydude for that. Give me a Irish person. And we've just made two instances. I don't really know, but this is what I'm going to use for instances just because they're cute, but this is not the proper use of these things. And which arrow should I have? One that doesn't seem to mean anything, that's what I'm looking for. How about you? Okay, so I need to join these up somehow. Okay, so we've got me. I'm June. Oh, what happened there? June and Ian. Okay, so we are instances of the class Irish person. Copy that. Okay, there's me and my brother. We are both Irish people. So we're going to cook spuds. Spuds are potatoes. And I'm not going to have, this is going to be all pretty much void. what's going to go in there yet. But we do know that we want to be able to cook potatoes. So far. Okay, let's add some complicated functionality here. And I'm going to have a list of Irish people that we'll iterate over to get them to all make their dinner. Okay, let's see how you like that. Okay, we've got a list, and I'm going to iterate over them with my for each, and then we're going to say, oh, nope, 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 no. Okay, then we're going to say Irish person, and potatoes. Okay, just so we can get something running and printing out so that I can show you how it's going to change. Okay, so here are me and my brother, and the default is boiling spuds. But this is going to get to be cooler because we're going to actually make a strategy. Now, I don't know if you're paying attention to the shapes that I was showing you earlier, but here we have a strategy. It's an interface, and then we have two implementers. You can have any number of those. It just happens that they're showing two. I'm going to have two as well because I want to be cool like them. This is going to be a spud cooking strategy. Oh, wow. And I'm going to put in here the method. Dump that there. The method is going to be prepare, for preparing spuds in different ways. So that's why I'm leaving it as a generic word here, because the things that are actually going to do the work are going to be concrete implementations of this interface. So let's have, which one of these will I get? How about you? I get two of those. Okay, so this is going to be for mashed spuds, roast spuds, and you can have a lot of variations of different potatoes. Just, you know, I'm sure, like you can have, you can make croquettes, you can have like double baked potatoes, stuffed potatoes, French fries, chips as we call them, and I sometimes feel like Forrest Gump when I'm talking about potatoes, the way he goes on about shrimps. That's how I feel about them. They're my desert island food. No, you're all coming or nothing. Alright, you go up there, you go down there, and let's get another one of those. Extends. There you are. Okay, you point upwards. I hope you all remember some of this UML. Okay, so we've got mash spuds that extend spud cooking strategy. This is not right. Because it's not an extension if it's an interface. We want implements. Implements is the one with a dotted line. That one. Sometimes, see, I got all distracted telling you about spuds and then I messed it up. So I'm going to try and, you know, keep off that. But it is dinner time. Okay, so now we have mashed spuds that implement spud cooking strategy and roast spuds too. Because they're implementing it, they need to have this method in here. Prepare, has to have the same name, has to have the same parameters, same return type. Okay, now the key part of all of this is the context, which is, for me, Irish person, context, is going to contain one of these strategies. And the whole thing about that, oh, I'm actually getting so excited to talk. Just thinking about this stuff, it just makes it beautifully flexible so that you can easily switch out the algorithms at runtime. Now, behave. Oh dear, let's see if we can do it like this. There we go. Thank you. Make it straight while we're at it. Okay, so now we know that we're going to contain a spud cooking strategy over here. And I'm starting to regret giving it such a long name. will do. And the type we know is spud cooking strategy. Okay, you'll probably never see another variable name like that again. Okay, we're going to also need a way to set the cooking method, and that's going to make it beautifully flexible so that you can switch those in and out at runtime. So I'm going to make space for another item in here, which is a method to set cooking method, and then as a parameter that's going to take a spud cooking strategy. I'm kind of regretting my long method names now. As a matter of style, I tend to use very long method names and variable names. Not everybody does that, but I like to be as descriptive as possible, which is fine when you have your control space in Eclipse, but not so much when you're making UML diagrams. Okay, so setting the cooking method there, that's going to set that. And then cook_spuds method is going to delegate the behavior to the spud cooking strategy, which is then going to go in there. If you're understanding this now, you'll possibly feel some goosebumps. Okay, I'm going to try and implement it. Oh, before I go, so the idea behind the strategy pattern, why not get the official definition, is that it enables, okay, what do I want to say? It enables selecting an algorithm at runtime. That's the key part. Okay, so these are algorithms. The preparation of the spuds or potatoes, those are algorithms. And this is an interface, so it shows what all algorithms that are related in this way need to do. We don't have any instance data for now. Okay, I'm gonna go implement some of this stuff, starting with adding the cooking method. Okay. That's a pretty standard thing. This is a pretty standard thing. I'm going to generate a setter. Just need a setter for now. And it's going to take as a parameter a spud cooking strategy, which doesn't exist yet. It's an interface. Some of these days I'm going to learn how to cut and paste. Okay, and what it's going to do in here is we're going to have a prepare method, which is void and takes nothing. Okay. That's good, that's good. This should be a spud cooking strategy, and that makes that not red anymore. Okay, so now let's go about setting some cooking methods on the Irish people. I'm going to set my cooking method to, oh yeah, we don't have that yet. So I'm missing out a key piece. The classes, that are the concrete implementations of spud cooking strategy. Yep, that's groovy. I'm okay with that red for now because I know that we need to add the unimplemented methods, which is prepare. It's getting that from here. Okay, so I'm just going to jam something in here. Okay, now I haven't put anything, all of this new code that I made, I haven't used it in here. Oh, I did, I put me as roast spuds. So, now we're getting boiling spuds and some roast spuds. Oh yeah, well, that's because I'm not using my cooking method in here under cooked potatoes. So instead of that, I'm gonna say Oh, I could actually even, yeah, no, I'm just gonna do this. Go away. Cooking method. Oops. Dot prepare. Okay, so I'm expecting to get one roast and one null pointer exception. Okay, that's because Ian, my bro, he doesn't have a spud cooking strategy yet. Let's set his cooking method to do mashed potatoes. Man, that guy can eat spuds like you would not believe. His nickname when we were kids was Bottomless Pit. Okay, so we've got one of each. There's me making the roast spuds, there's Ian making the mashed spuds, and you can see how easy it is to switch these out. So I can, you know, say it's Monday and, or if I have a sore throat, I want to make mashed spuds, so that's super easy to do. This is giving a lot of flexibility. It makes this code reusable, so I could use this elsewhere. And it's quite lightweight. Except, you guys know that I'm not a huge fan of inheritance. This is definitely a little clunky. Now, hopefully, after doing the Lambdas lesson, you'll see a sort of familiar thing here. And that's an interface that has only one method. That's got a special name in Java. It's a functional interface. We've come across some functional interfaces in the past, like comparable as a functional interface. It has just one method compared to. And this this will make sure that I can't have more than one method in here. If I had another one. It's not a functional interface anymore. So this annotation is calling me out. The reason you might use that is if you were making something that was architecturally possibly similar to this, you might want to warn other programmers that this should be a functional interface, don't add more methods. Okay, so what I've made here is this. And the next thing I'm going to do is I'm going to use the new knowledge that we have to lambdaify it. All right. I'll just put me back to roast like that. Make sure we're all compiling. All right, so because we have just one method, we could use an anonymous inner class. So instead of doing this, oh, by the way, so what I'm trying to actually get to is I don't like all of this. This is too heavy, and we should be able to refactor it down now that we have lambdas. The reason that I have these classes is the mashed spuds and roast spuds, those are wrapping the behavior, and that's the only part that we care about, just the functionality that's in here. But with old Java, everything had to be inside of a class, wrapped up like that. So now I'm going to go back to the new way. So what you would actually do here is not have a new mashed spuds, you'd make a new anonymous instance of spud cooking strategy, and this is where you would do the implementation. Okay, there's that. I'll just do one at a time. Okay, then there's this. Okay, does it work the same? It works the same. However, there is a significant difference in that now we can blast this away. Sayonara. Okay, we're getting places. And now, because we were looking at some things like this, how you can reduce this down to a lambda. So I'm going to do that. Okay, bye. Put in your lambda like that, and I'm going to have an extra curly brace. Just going to check that it still works the same. Yes, so I'm going to do the same down here. We don't need the spud cooking strategy, we just need the parentheses, a lambda operator. Okay. Alright, so all this was possible because I had a functional interface that had just one method. See, I'm not saying what I'm implementing here. I'm not saying I want to override the prepare method, it knows that because it's seeing that there is only one method in spud cooking strategy, so then it's going to automatically make the implementation that. Okay, one more thing is that we are provided with many functional interfaces by Java 8, and those are here. Java function package, Java function package. Okay, this is a super useful page. All of these are functional interfaces that are provided by Java, so you wouldn't actually need to make your own. Like I made my own there. Mine is the spud cooking strategy, a ridiculously named functional interface. Here are some nicer names of ones. So usually what you do is you wouldn't write your own. You'd come here and you'd see if there was one that already did what you wanted. And the way that you decide which one is you figure out which inputs it has. So whether, so I say if it's like a function, this one we were using already. Okay, so it takes, in the crocodiles, 2 parameters. One is the input type, and then you got the return type. I'm just going to go back to this thing that we had where we were doing the writing lambdas there. Okay, so these are all different kinds of functions, see? So these are all different functional interfaces, and function is taking different stuff. So when we're operating on integers, that's the input and return type. When we're operating on strings, it's different, and characters, etc. Here's an interesting one, by function. So this was the Pythagorean lambda, and that was where you wanted to check that the square of the hypotenuse is equal to both of these sides. So we had the result, so we had the side A, side B, and then we had the result. So it had 3 integers in there, and then I had to go and look for a by function for that. So I was like, how am I going to do this? I've got 2 inputs, I've got 1 output, and then I came in here and I looked and I found here's a function that accepts 2 arguments and produces a result. Okay, now this isn't a very good, this isn't a very complicated example. This spuds. So my method prepare is unusually sparse. It doesn't take any inputs or return anything. So let's see, to choose one of these, I'm going to just search for no results. So what I'm looking for is something that does not return a result and that does not have an input. Single input, 2 inputs, single double variable. I think that I might not get one long. Okay, so I'm just going to pick the closest thing, which is consumer, represents an operation that accepts a single input argument and returns no result. We're going to have to put, some jazz in as our single input argument. So consumer, I'm going to grab this consumer, and instead of having my own defined functional interface, I'm going to stick this consumer in here. What type is it? Well, this is doesn't really matter, but I'm going to put integer. That's what the input's going to be. And I need to change it here too, so that it compiles. Okay, so the consumer method, we can go in here and have a look-see. Okay, so here is its methods, it's accept. So I would come in here, and instead of saying prepare, I say accept. And I think it wants a parameter. Yep, it wants a parameter. How about 0? I'm kind of hacking this because my requirements don't line up with this function. I just wanted to show you guys how you would probably use your own. You would use one that's part of Java rather than rolling your own. Okay, up here you're complaining because the arguments, okay, so here I've got the parentheses with no argument, and it's expecting, the consumer is expected to have an integer, so I'm going to jam in a useless little x there just to make it work. Okay, now I think that was probably a bit hardcore for most people, including me. But what I did in summary was created a strategy pattern and then refactored it down to use lambdas. And the original version, the original strategy was a lot more cumbersome. It had a lot more inheritance, and I think this one's more readable and more lightweight. Also, even if you wanted, you could take this lambda and you could extract it and you could use it somewhere else. you know what, this should be nicer anyway. We don't want you, we don't want you. And then that's go away. Let's format and add another parenthesis. So what I was trying to say was, if I wanted to reuse, this lambda doesn't do all that much, but if I wanted to reuse the function, I could extract it. It shouldn't be called cooking method though, so I'm going to go back on that. I'm going to select it again. I'm extracting local variable, refactor. This is actually mashed spuds cooking method. So that thing, that lambda, I could use that wherever I wanted, hypothetically. I could even use it outside of this class. Okay, so see, reusable, lightweight, functional, awesomeness. Okay, you'll be happy to hear that I'm not going to make you do all of this. I have a pretty more pared down exercise. It's called Spice World. This is a functional interface. Perform. What you have to do is remove the anonymous inner class, which is this, and put it down into a lambda. Okay, see you later. Bye.